Welcome to our channel. Today we're diving into the fascinating world of minerals. Minerals are all around us. They make up the rocks beneath our feet, the mountains in the distance, even the sand on our favorite beaches. Minerals are essential for life itself. We'll explore the different types of minerals, from shiny gemstones to the hidden minerals inside our very own bodies. We'll discover how they work in nature, forming incredible crystal structures and shaping our planet. And we'll learn how these amazing materials play a crucial role in our everyday lives. So get ready to unlock the secrets of the mineral kingdom. We're going on an adventure to explore the building blocks of our planet and beyond. Let's get started. Now, before we journey deep into the Earth, let's make sure we know what we're looking for. What exactly a mineral? A mineral is a naturally occurring inorganic solid with a definite chemical composition and a specific crystal structure. Naturally occurring means minerals are formed by natural processes, not made in a factory. Inorganic means they're not derived from living things. Solid means they have a fixed shape and volume. They're not liquids or gases. Definite chemical composition means each mineral has a specific recipe of elements. Minerals are incredibly important for a whole bunch of reasons. Now that we know what minerals are, let's talk about how scientists organize this vast mineral kingdom. Minerals are broadly divided into two main groups, silicates and non-silicates. Silicates are the most abundant minerals on Earth, making up about 90% of the Earth's crust. Non-silicates include minerals important for industry, like iron ore and copper ore, as well as beautiful gemstones, like diamonds and rubies. We'll delve deeper into the specifics of both silicates and non-silicates in the following chapters. Let's shine the spotlight on the superstars of the mineral world, the silicates. The basic building block of all silicates is the silica tetrahedron. Imagine a pyramid with a triangular base. That's a tetrahedron. In the center of this pyramid is a tiny silicon atom, and at each of the four corners is an oxygen atom. This simple structure is the key to the incredible diversity of silicate minerals. These silica tetrahedra are like tiny building blocks that can link together in countless ways. They can form chains, sheets, or even complex three-dimensional frameworks. The way these tetrahedra are arranged determines the properties of the resulting mineral. For example, quartz has a very strong, three-dimensional framework of silica tetrahedra. Now let's move on to the less common but equally fascinating non-silicate minerals. These minerals are diverse and play essential roles in our lives. One important group is the carbonates. They contain carbon and oxygen bonded together. Calcite, found in limestone, is a familiar carbonate. Limestone is used to make cement and build roads. Oxides contain oxygen bonded to a metal. Iron oxides, like hematite, are sources of iron ore. Aluminum oxides, like bauxite, are sources of aluminum. Sulfides contain sulfur bonded to a metal. Important metal ores are sulfides, like galena and sphalerite. Halides contain a halogen element, like chlorine. Native elements consist of just one element. Ever wondered how these amazing minerals come to be? It's a fascinating journey that often starts deep within the Earth. One of the main ways minerals form is through crystallization from magma or lava. As magma or lava cools, the atoms within it start to slow down and arrange themselves into orderly crystal structures. The type of mineral that forms depends on the chemical composition of the magma or lava. For example, magma rich in silica and aluminum will tend to crystallize into feldspars and quartz. Minerals can also form through precipitation from water. This process often occurs in evaporating lakes or seas. As water evaporates, the dissolved minerals in the water become more concentrated. Eventually, the water becomes so saturated with minerals that they start to precipitate out of solution, forming solid crystals. Another way minerals can form is through the process of metamorphism. Metamorphism occurs when existing rocks are subjected to high temperatures and pressures. Let's take a journey inside our own bodies. Minerals aren't just for rocks. They're essential for life. Our bodies need a balance of minerals to function. They build bones, regulate heartbeat, and transport oxygen. Calcium is crucial for bones and teeth. It also aids muscle function and blood clotting. Iron is vital for oxygen transport in blood. Sodium regulates fluid balance and nerve function. A balanced diet ensures you get all essential minerals. Minerals are essential for life, but they're also essential for our modern way of life. From the smartphones in our pockets to the skyscrapers that shape our skylines, minerals are the building blocks of countless products and technologies we rely on every day. Let's start with construction. Minerals are the foundation of the buildings we live, work, and learn in. Limestone is a key ingredient in cement and concrete. Gypsum is used to make plasterboard, also known as drywall. Granite is a popular material for countertops, flooring, and building facades. Now, let's talk about electronics. Our smartphones, computers, and other electronic devices rely on a wide range of minerals. Silicon is the foundation of the microchips that power our devices. Copper is used for wiring and electrical connections, and rare earth elements are essential for making magnets, batteries, and displays. The automotive industry is another major consumer of minerals. We've seen how essential minerals are to our lives, but have you ever stopped to think about where these minerals come from and how they're extracted from the earth? The first step in mineral extraction is exploration. Geologists use a variety of techniques to locate and assess mineral deposits. They study geological maps, analyze aerial and satellite imagery, and conduct geophysical surveys to identify areas where mineral deposits are likely to be found. Once a potential deposit has been identified, exploration drilling is conducted to collect samples and determine the size, grade, and depth of the deposit. If the deposit is deemed economically viable, the next step is mining. There are two main types of mining: surface mining and underground mining. Once the ore has been extracted from the ground, it's transported to a processing plant. While mineral extraction is essential for our modern way of life, it's important to acknowledge that it can have significant environmental impacts. From habitat destruction and water pollution to greenhouse gas emissions and the displacement of local communities, mining can leave a lasting footprint on the planet. One of the most significant environmental impacts of mining is habitat destruction. Surface mining, in particular, can remove entire mountain tops, forests, and wetlands, destroying critical habitat for a wide range of plant and animal species. Water pollution is another serious concern associated with mining. Mining operations often generate large volumes of wastewater, which can contain heavy metals, acids, and other contaminants. Air pollution is another concern, particularly with mining operations that involve blasting, drilling, and the transportation of ore and waste rock. It's crucial that mining companies operate responsibly and implement measures to minimize their environmental impact. As we look to the future, it's clear that our demand for minerals will only continue to grow. The global population is increasing, and with it, the demand for housing, transportation, electronics, and other goods and services that rely on minerals. One of the biggest challenges facing the mining industry is the need to operate more sustainably. Traditional mining practices have often come at a high environmental cost, but there's a growing recognition that we need to find ways to extract minerals while minimizing our impact on the planet. Thankfully, there are a number of promising innovations and trends emerging in the mining industry that offer hope for a more sustainable future. Improved exploration techniques are enabling mining companies to more accurately identify and target mineral deposits. Enhanced mining methods offer the potential for more targeted and less invasive extraction methods. The mining industry is increasingly implementing water conservation and reuse strategies. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe for more fascinating content. Be sure to share this video with your friends. Everyone can appreciate the wonders of minerals. Remember, the world of minerals is vast and full of incredible discoveries. From the tiniest grains of sand to the towering peaks of mountains, minerals shape our planet and our lives in countless ways. Stay curious and keep exploring the wonders of science. There's always something new to learn about the natural world around us.